Hi, Haran. How are you? Hello, am I audible? I think your voice is, I'm unable to listen to you. Your voice is not audible for me.
Hi Chaitanya. Am I audible now?
Yeah, yeah, you are audible. Thanks. So, yeah, let's start the session. If anybody joins, they will start joining in the middle. So, the point what we need to discuss here is yesterday's session itself. I said you that we'll be going ahead with the Terraform configurations. Okay, so we'll be starting with the Terraform configuration. So what is meant by Terraform and how we are going to work with the Terraform? These are the things that we are going to discuss here. Any which ways, what is meant by Terraform first? Okay. Terraform is a infrastructure development tool or else infrastructure creation tool with the help of code. Terraform is an automation tool which will be helpful for developing or for creating the infrastructure in the different clouds, different cloud environments and on-premises also, on-prem environment also. So on-premises in the sense virtual machines. Okay, if you want to create any virtual machines with the help of VMware, we can create the Terraform. So this is infrastructure as a code. So Terraform is an infrastructure as a code. So what we are going to do here is we will create the code in the HCL language. So what is meant by HCL language? Sorry, HCL Terraform. If you can see HashiCorp language. If you can see HashiCorp configuration language. HCL means HashiCorp configuration language. HashiCorp is the main what I can say main pillar behind the Terraform. Terraform is developed with the help of Terraform is developed by HashiCorp engineers. So that's why it is called as HashiCorp configuration language, or HCL is a declarative language used by the Terraform to define the infrastructure as a code. So this is the one thing. So we will create the code in HCL language, HashiCorp configuration language, and we will have different providers for different environments. So if you are using AWS, for AWS you will have the AWS providers. If you are having providers are nothing but the plugins. So in AWS you need to create the VPC. That API you must know. So to know which API I have to use, to know which cloud API, cloud resource API that Terraform has to use, that will be defined in the defined in the providers plugin. Okay, so first what we need to do, we need to mention in the Terraform code. First of all, what we need to do here is we need to mention that provider. Who is the provider? So if AWS, then we need to make that provider. So this is how the syntax will be. Provider is AWS for AWS, and like this we have to mention, or else provider. For example, if we are creating Azure, then the provider will be provider Azure RM. So like that we have to create. We have to give the code. When we give the code in this fashion, then what Terraform will do? Then Terraform will download the required plugins required plugins depending on the provider, whatever the provider that you have provided, depending on that relatable plugins will be downloaded. For example, if I give AWS as provider, so then Terraform is going to download the AWS related plugins. If I give Azure RM or else Azure related provider, then AWS will download the Azure related plugins. So to create the necessary resources in that particular environment. So this is what Terraform is going to do. And one more thing here is Terraform is idempotent. Terraform idempotent. So what is meant by idempotent? In Terraform, idempotency means that running the Terraform apply multiple times with the same configuration file will result in the same end state without unintending side effects or resource duplication. So what is the meaning of this particular sentence? So if you want to know about that, first of all, you need to know about the Terraform workflow. Terraform workflow. So how Terraform will work. So first what we are going to do here is, first we are going to write the code. Write the code in HCL language. Okay, HCL format. HCL means HashiCorp configuration language. Once we have written the code, then we need to validate the code. Validating the code, whether whatever the code that was written by us is correct or not, we need to validate that. And then we need to do the doing, or else we have to plan which resources is created. So which resources will be created with the help of the code. Okay, so whatever the code that we have written, so which type of resources will be created. If you want to check out that, then you can do a dry run without creating the resources. We can check out which resources will be created if we run this particular code. Which resources will be created and as well as which resources will be destroyed. I will simply give like destroyed. Okay. And then finally we will go for Terraform apply or destroy. So what is the meaning of that? When we go for Terraform apply, then let me go with the apply itself. When I give the command Terraform apply, then the resources will be created in the cloud. So whatever the cloud that you are having, the resources will be created inside that particular cloud. Okay. And the next one is, if you go for destroy, Terraform destroy, then the resources will be deleted. Then the resources will be deleted. Okay, this can be done. So this is the workflow. So writing the code, validating the code, and planning which type of resources will be created with the help of the code which we have written. And then applying the code. When we apply the code, automatically the resources will be created. And finally, we can provide the destroy. Destroy means the resources will be deleted. So these are the multiple workflow locations. Okay, workflow ways. Okay, so here what is happening, step-by-step process will be taking place. Now, when we create the resources, when Terraform creates the resources, then a state file will be created. A state file will be created, which is the entire heart of your code. So the state file is very important, in which we will have the resources, whichever the resources that are created, which we will have the created resource information. For example, I created the VPC. So in the Terraform state file, it will be updated like a VPC is created. So, and then what is the CIDR block of that VPC? What is the VPC ID? What is the name of the VPC? Everything will be updated in the Terraform state file. So the Terraform, we are calling that Terraform is idempotent. Okay, idempotent in the sense, that is what the meaning which I said you here. Idempotency means that running after Terraform apply. When we apply the Terraform, multiple resources will be created. Okay, so when the multiple resources are created, what is going to happen? Terraform will go and check in the state file. As I already said you, so there will be a state file going to be created, and this state file, whatever the state file that is created, now what Terraform will do here is, whenever if there are any changes, if something I have to add into that resources, or else if I have to delete some resources, every time it is not going to recreate the resources or duplicate the resources. Simply it will go and check the what I can say, it will go and check the state file. So whatever the state file that has been created when we apply the Terraform apply command, so then it is going to going back to the Terraform state file, and it is going to check what are the resources that are created. So we will be having a code, and with the help of the code, it is going to cross check with the Terraform state file. And when the Terraform state file is cross checked, then Terraform will understand that, okay, these are all the resources are already there. They're already available in the cloud. So I need to create only this particular resources, which means that it is not going to duplicate the resources. This scenario is called as idempotency. That is what here it is mentioned. Idempotency means running the Terraform apply multiple times with the same configuration will result the same end state without unintended side effects or resource duplication. Essentially, a Terraform detects what changes are need to be reached to the desired state defined in your configuration, only applies those changes. Whenever a new change has been made, then those changes will be applied. So to understand that, let me do one thing. So these are the basic concepts. So whenever somebody asks you what you know about Terraform, then you have to say that Terraform is an automation tool which will be helpful for developing the infrastructure in the multi-cloud environment and as well as on the on-premises environment. And next one is we can create the resources. So Terraform is called as infrastructure as a code. We are going to write the code in the HCL language, that is HashiCorp Corporation language. And we have to define the providers. When we define the providers, Terraform will download the relatable plugins, and with the help of those plugins we can create the resources in that particular environment. And Terraform is idempotent, which means that whenever we create a resource, the resource duplicate, when we reapply the configuration, the resource duplication will not happen. So this is what you need to tell. So you might have a doubt. So what is this resource duplication process? So let me tell you one thing. So if I show you practically, you will understand the configuration. For example, let me log on to my AWS environment. In the AWS environment, I want to create a VPC. Manually, I can create the VPC, but this time I will be going with the shell scripting process. So to do so, what I will do here is shell server. I'll go with Amazon Linux T2 micro. So see here, I am going with the Amazon Linux server T2 micro, and key pair will be default key pair. I want to create with the help of dev public subnet and select an existing security group. I will go with the default security group. Okay. And launch the instance. The server will be deployed. Okay. Once the server is deployed, then what I have to do? So to this server, so now what is my requirement? Whenever I apply the certain commands, the server has to create the resources for me. Okay. So before I go into the further process, Hariharan, do you have any questions related to this? Whatever I said, do you understand about the topic?
Yeah, I understand you, sir. But one doubt is
Hmm.
you are about to you are creating the instance, the EC2 instance only. You are not creating a VPC, but you mentioned that you are going to create VPC.
First, just focus on this. I will tell you. Okay.
Okay.
So
Okay.
I'm creating the EC2 instance. This EC2 instance need to create the instance need to create the VPC. So let me show you that. I'll copy the public IP. Let me log on to the server EC2-user. As it is an Amazon Linux server, the default user is EC2 user. So when I log in into this server, Okay, so to create the resources, so what should be done? My server has to create the resources. If my server has to create the resources in the AWS environment, first of all, my server needs to have the AWS CLI, AWS -- version. Here you can see AWS CLI is by default installed in the Amazon Linux, so we don't have any problem. So the next one is this server has to create the resources. This server, in the sense, whatever the shell scripting server or shell server that I have created, when I pass the commands, for example, AWS EC2 describe -vpcs. If I give this -- region is US East 1. When I give this, so here you can see unable to locate the credentials, which means that my server has to retrieve the data from the particular AWS account. So here the server is created. Of course, the server is created in an AWS account, but still, if the server has to be where it is created, this server is created in an AWS data center. Somewhere in US location, it is created inside a data center. And this server has to go to the my AWS account. So this is my data center in which the server is created. What is the server? Shell server. This server has to go to the AWS environment and it has to fetch out the details from that AWS environment, or else it has to create the resources in this AWS account. Whatever my AWS account is there, into this AWS account, it has to connect and it has to create the resources. But what is the problem here? The problem is if it has to log in into my AWS account, this server should have the access. So I will provide the permissions for this server. Let me provide the permissions, or else I'll go to IAM. IAM is the what I can say permission store, where it is going to provide the permissions for the users and as well as for the servers. So here I am going to create a role. Roles, create role for EC2. Next, admin access _ds. So this is the sorry. I will provide the administrator permissions and the name of the role will be admin access _ds_role. So this is the role that I am going to create for that particular server. So when I create the role and I am going to apply this role, whatever the role that we have created, admin access _ds_role, this role I will be applying onto the server. Actions, security, modify IAM role, admin access ds role, update the IAM role. When I update the IAM role, so now the server will have the privileges to access the AWS, my AWS account. So let me go back here. So if you can see AWS EC2 describe VPCs, I am able to get, my server is able to get the VPCs. Why? Because I have applied the role. Previously, I did not apply the role. So I am going to get unable to locate the credentials. When I apply the role, automatically my server will be able to log in into my AWS account. And from there, it is able to fetch out the details. So now, JQ. Here you can see what are the different VPCs I am having. I am having the dev VPC, and then I am having the dev app VPC, and then I am having the web app VPC. These are the three VPCs that are created. Okay, this is fine. So I want to get only the VPC IDs. So simply what I can do, jq.vpc.vpc ID. If I give this, then I will get the VPC IDs here. There are three VPCs in this particular region. If I go with US West 1, which is North California region, in North California region also, I am having three VPCs. So if I have to know what are the name of that particular VPCs, what I can do here is VPC ID, comma, dot tags, dot value. If I give like this, now here you can see we are having dev VPC, prod VPC, test VPC in the US West 1. Okay, if you go for US East 1, the same. You will have the dev VPC, dev app VPC, and web app VPC. These are the three VPCs that I have. So I am able to fetch out, the server is able to fetch out the details. Why? Because we pre-applied the configuration over here. Okay. So this is one of the use case of applying the IAM role onto the VPC. And the next one will be, for example, if I want to create an VPC. So let me write a shell script for us. So I will go to D drive. Here I will create a folder. New folder, temporary. So vpc.sh. If I create this shebang /bin/bash. Okay. So what I can do here is I'll go back to Google. Okay. AWS EC2 create -VPCs, create VPC. So this is the command to create the VPC here. AWS EC2 create VPC --cider block. If you can give this, then the VPC will be created. Okay. So I'll go back here. And then what I can do, I can provide the tag specifications also. Let me copy this. --tag specification is equal to resource type VPC, tags is equal to name, and VPC name will be my project. So simply I will give this tags and I will try to create the VPC with the help of this particular command. What it is saying, invalid parameter for tag specification, tags comma value, key is equal to name, and type is equal to string. String means I have to provide this in a double quotations. That's it. Let me provide it in the double quotation. And the CIDR block, what I will do here is 10.50.0.0/16. I will provide in this fashion. Okay. So if I copy this and I will try to create the resource in my AWS environment. Tag specification dot tags value name type string, valid type is equal to string. So invalid.
Try single quotes.
No, not the single quotes. I think. Okay. Any which ways, as you have asked me, I'll go with the single quotes. Actually, it should be the double quotes, but let me recheck this. Okay. So there is an error. Let me recheck that tag specification. So what I can do here is, let me go back over here. AWS create VPC. Okay. Create VPC --cider block --tag specifications. Okay. Here you can see we are having the tag specifications. And then what is my requirement over here when I go for tag specification? Tag specification, resource type. Resource type is a string. Resource type is VPC. I think I have to provide the double quotations over here. Let me check out this once. Key and value. So resource type is equal to string. Tag key value. Like that we have to provide. So tags and key value is correct. This is correct only. Whatever we have provided is correct. Tags is equal to key, that is equal to name, and value is equal to my VPC.
Name also should be in double quotes, I think.
No, not required.
First of
all, here we don't require any double quotations. Let me remove the double quotations, or else let me go with this. Why I don't want to waste the time. So Let me check out the configuration over here. AWS create VPC. What was the error that we are getting? The error is invalid type for the parameter. So when I check out this, due to the incorrect syntax, tag specifications. Yeah, here, there you go. So this is what I am forgetting. So I think there should be a single quotes for this particular config here. This should be a single quote. Okay, so the rest of the thing is fine. So when I try to create this, when I give it over here, this time the VPC is created in my US East one. So if I go back here, let me go to the VPC in US East one. Okay, so I will go back to the VPC. If I go to the VPCs over here, you can see my project VPC is created with the CIDR 10.50.0.0/16. This is fine, but shell scripting is not idempotent. What is the meaning of that? So shell scripting just blindly follows the command, whatever the command that I have given. So now what I can do here is I want to get the VPC ID value. So here we have created the VPC. Okay, so whatever the VPC that I have created, if I want to know the VPC ID, so now what I can do here with the help of tag specification, we can get the VPC ID value, but that's okay. So now let me copy this VPC and then I want to create the subnet. Okay, I want to create the subnet. AWS create the subnet. In which VPC I want to create the subnet? Just now we have this VPC ID. Okay, I will tell you in the upcoming time, but as of now, AWS EC2 create subnet. AWS EC2 create hyphen subnets. Okay, create hyphen subnets and then create hyphen subnet, and we need to provide the CIDR block. Hyphen CIDR block is equal to 10.50.1.0/24, and then we need to provide the availability zone. Hyphen availability zone is equal to US hyphen east, US hyphen east hyphen 1. Okay, so this is one more thing that I want to create, and the next one is VPC ID value. Hyphen VPC ID value is equal to this one. This is the VPC ID. And then what I need to provide here, I am telling to the shell script that you need to create a subnet in this particular VPC ID. Okay, in this VPC, which is having the VPC ID in this format. Hyphen tag specification is equal to resource is equal to subnet. Hyphen tag specification resource is equal to, okay. So if you go down, is it? Resource type is subnet will be there. Where is it? There you go. Subnet. Okay, so I just want to recheck that. So subnet. This is the resource. Okay. This is the resource which I want to create. And the next one is tag is name. Value is my project hyphen subnet hyphen 1 or subnet 1. Simply I will give like this. When I give this, what is going to happen? Here there will be a problem. If I execute both the commands, let me copy it. Nano vpc.sh. If I execute both the commands, we are having in the shell scripting code, we are having both the commands. Then what is going to happen? Bash vpc.sh. Here VPC is already created and as well as subnet is also creating. Nano vpc.sh. A duplication of assets are happening. Duplication of resources are happening. So this is what the main intention of idempotency. When I create the VPC again, So here you can see the subnet is getting created. Okay, an error occurred while calling the create subnet operation. Value is east 1a. Nano vpc.sh. Here, what is the problem here? Here, the availability zone value is US east 1a, not 1. Okay, that's fine. No problem. So the subnet will be created. But what is happening here? The duplication of VPC is happening. Already we are having the VPC. Again, what we are doing, I mean, whenever we apply that configuration, it is creating another VPC also. So this will not happen. So here you can see there is a duplication of VPC is happening. Previously we are having this VPC. Now when we create or else when we add another subnet, for example, here we are having subnet 1. If I add the another subnet, what is going to happen? It will try to create another VPC. So this time it will be US East 1A and this time it will be US East 1B. And CIDR block is 10.1.50.2.0 and subnet name is 2. So now when I apply this, what will be happening over there? Let me check out that. Nano vpc.sh. Okay, when I give this bash vpc.sh. So if you can see, oh, sorry. What is the problem here? The problem is I have given the subnets. That's the problem. Apart from this, nothing. Okay. Nano vpc.sh. Okay. I'll give like this. Bash vpc.sh means see that subnets are getting created. For example, if I want to create another subnet, then what will be happening? Then I will be replicating the same configuration again. So now subnet 3, the CIDR block is 10.50.3.0. This is the CIDR block. And in which availability zone? In the availability zone US East 1C. So actually we are thinking that only one VPC will be created, only one subnet will be created, only. So like that, what we are thinking when we are upgrading our VPCs, what is happening here? Okay. So now here you can see we will be having the multiple subnets. Let me go back to here. I'll go back to the subnet. So if you can see, we will be having the my project. So that's the duplication of your resources. My project subnet 1, subnet 2 and subnet 3 has been created. This is fine. But when you come back to the VPCs, then why we are getting this kind of resources are getting created? These resources should not be created. These resources should not be duplicated. The main reason here is, does this particular Linux shell script have any log monitoring point? Log monitoring point in the sense, what are the VPCs that are created with the help of these commands? Does this particular shell script will be able to look after the what are the VPCs are created, what are the resources are created? Does it have any sort of what I can say monitoring system like that, or else does it have any type of understanding? Okay, so these are all the VPCs that are previously created. Now we need to create the additional resources. It doesn't have that monitoring state. Okay, but in Terraform it will have the monitoring state, so that what is going to happen, this VPC is already created, so I just need to read the data. That's it. It is not going to recreate the VPC. But here when we are using the shell scripting, what is happening? It is creating the duplicate object. Okay, so that's the main problem with the shell scripting. So to overcome all these problems, what we are doing, we are going ahead with a process called as Terraform. Okay, do you understand why we are going for the Terraform?
Yes, Sultan. Yes.
Okay, so now let me go back to the Terraform configuration, what I have to do in my laptop. So what I will do, first of all, I will download the Terraform, terraform.io. Okay, so I will download the Terraform into my Windows operating system. Already I have the Terraform, but I am just showing you for your understanding purpose. Download. Okay, so I'm downloading it. Here you can see we are having the Terraform which I have downloaded right now. I'm going to extract the file, extract it, and then whatever the Terraform that we are having, let me cut this application. This is a binary file. I'm going to cut the application. Go to DURGASOFT, temporary. So here I will give the data, whatever the application that I have copied. So now copy the path, whatever the path is there, copy this path, and we are going to set in the environmental variable. So go to sysdm.cpl or system properties. Go to the system properties. In the system properties, go to the advanced environmental variables. Go to the source, path, edit the path, and add the variable over here. So when I add the variable over here, so the Terraform binary will be an executable binary anywhere in my location. So now what I will do, I will open the PowerShell in this particular directory. Okay. So now what I have to do here is Terraform version. When I give this, so then it is going to show me the current Terraform version, which is a version 12.2. This is fine. Now it's time to write the code. So what is the first step that we have to do for working with the Terraform? We need to write the code in the HCL language. So I will create a new Terraform underscore basics. I'll go back to the PowerShell, cd Terraform basics. In this folder, what I can do here is I'll go ahead for initializing. First of all, we need to initialize the Terraform. To initialize the Terraform, I will open the Visual Studio Code. Here you can see I have opened the Visual Studio Code. Here I will write the main.tf. Main.tf I am going to write like this. So what is this main.tf? In the main.tf, I need to define the provider. So for example, so I want to write the code. If you want to write the code, simply what you can do here is you can install the extensions. So try to install the extensions called as Terraform. In the Visual Studio Code, here you can see the extensions. Install these two extensions, HashiCorp Terraform extension and this extension also. These two extensions, you can install it in the Visual Studio Code. Then what will be happening whenever you are writing the code, provider AWS. Simply I will give like this, provider is AWS. So now when I initialize the Terraform, so here you can see a file is created. In that particular folder, a file is created, main.tf. So I'm initializing the Terraform in that particular directory. So how I can initialize that? Terraform init. When I initialize that, it will understand, okay, the user is using the AWS as default provider or else AWS as the cloud service provider. So I need to download the AWS related plugins. So it is installing and downloading the AWS related plugins for the project. Okay, so if you think one of the project is coming from the AWS environment, so simply what you have to do, you have to give like this. Provider is AWS. Here you can see a folder has been created. .terraform directory has been created. Inside that .terraform directory, what you will be having here is you will be having the plugins, whatever the plugins that are required to run. So for example, I want to create a resource, VPC. So if I want to create the VPC, Terraform has to communicate with my AWS account and it should create the VPC. For creating the VPC and for communicating with the AWS, I need to have the plugins. So that's why I have initialized the Terraform here, and it downloaded and downloaded all the plugins, and that will be available inside this .terraform directory. If you can see the size of this particular directory, the size of the directory is 708 MB. Okay. So now what I can do here is I will do one more thing also. So I want to make this code available for all my students. So for that purpose, what I will do here is I will initialize the Git. Okay, so I want to make sure that you understand Git also in this particular course. So what I will do, I will initialize the Git. Okay, so what is meant by a Git? Git is a distributed version control system. So what is this distributed version control system in the sense? I'm now taking you to the Git. So right now we are in the Terraform. We have initialized the Terraform. Terraform has downloaded all the required plugins for our whatever the provider is. So up to here it is completed. Okay. Now, before I write the code, so what I want to do here is, I want to make sure that you understand the Git also. So Git is a distributed version control system. So here we are having two types of version controls. One is the centralized version control system and the other one is the distributed version control system. So what is the centralized version control system? So if you are having a code, okay, so there are certain developers who are going to write the code. So in the centralized version control system, all the clients should be connected to the centralized repository that is called as central server. So every time when they want to make the changes, they will be making the changes only in the server. Okay, they are not going to download that and make the changes in their local system. So what they will be doing here is the developers or else the client C1, C2. So like that, you will be having multiple clients, multiple developers will be there. So this is my central repo, or I will call it as central server, which is hosted on either on the internet or else it might be in a company server. Now, whenever any client has to make any changes, they have to connect to the server. In the server only, they have to do the changes. So if the client too want to make the changes, he also need to connect to the server. So now the point here is, if they are unable to connect to the server, whatever the changes that they want to make in their code, that will not be done. So this is the main drawback of central version control system, CVS. Okay, so that is what we will call it as CVCS. Okay, so to overcome this problem, we are going with another concept called as distributed version control system, which is a Git, or else I will call it a centralized server is called as GitHub, or else we will having a Bitbucket, and we are having the GitLab. These are the multiple tools that we are going to use. In this, what we are going to do here is, we will be using one of the application as a centralized server. But in my client machine, I will be installing the Git. Okay, I'm going to install the Git. So just give me a second. So here you will be having the Git. Okay, so we are going to install the Git in locally, and in all the systems we will be installing the Git locally. So when we install the Git locally, what is going to happen? Whatever the code that you have written, for example, client one is the manager. He has created a repository in his local system and pushed this repository to my central controlling or central server. So in the GitHub or else in any another tools, you will be having a repository available. And what the other client can do here is, the other client or else the other developer can download this particular repository in his local system. So that is not available in the what I can say, that this particular feature is not available in the central version control system. So he is not able to download the code. But in the distributed version control system, what can be happen? So whatever the code that was there available inside this GitHub, so the other person can be able to download that particular code into his laptop, and he will be able to make the changes into the code if he is offline also. So why? Because the code is available offline. So whatever the changes that he want to make inside the code, he will make the changes inside the code. And then what he can do, he can push this repository into the GitHub back. Okay, so this is what called as distributed version control system. So we will be having a local copy of the code, and as well as we will have the remote copy of the code. So whenever the internet is there, we will be able to connect to the remote repository, and whatever the changes that we have made, we will be able to push the changes into the remote repository. So that can be happened here. So that is why it is called as distributed version control system. So for all the employees, so that one local copy can be downloaded and they will make the changes in their respective modules. So what I am going to do here is, this is called as Git. I am going to initialize the Git in my Terraform basics folder, Git init. So whenever I have initialized the Git, so now what is going to happen here? So if you can see here, you can see certain files will be marked as U and U. So U means untracked files. Whatever you are seeing here, U symbol, this is the meaning called as untracked, which means that Git doesn't know about those files. And one more thing that you need to understand here is when we initialize the Git, automatically a folder, a hidden folder will be created, and that hidden folder is called as .git folder. In the Terraform basics, here you can see .git directory is created. It's a hidden folder. Inside that hidden folder, here you can see we are having the objects. So right now we are not having any sort of objects over here. This is fine. So now when I come back to here, I will give git status. So what it is saying, so the Terraform log.html file is untracked, and the .terraform directory is untracked, and main.tf is also untracked. Whatever the files that are located in this particular directory, they are not known by the Git. Untracking means Git doesn't know about that particular files. So now what I have to do, but one most important thing what you need to understand here is this Terraform directory, whatever the Terraform directory is there, the .terraform directory is a very huge directory, which is having 700 MB of size. This much amount of size folders cannot be moved into the Git. So I don't want to move this .terraform folder into the Git. Okay. So for that, what I have to do here, so here you can see I want to ignore this .terraform directory. So Git has to ignore about this .terraform directory. Why? Because I don't want to push that code into my, I don't want to push that .terraform directory into my GitHub. So why? Because it is very huge of size. So Terraform will not allow that. Terraform will allow maximum file size with the file or folder size with the maximum of 100 MB. Okay. So, but if you can see this .terraform directory is having 700 MB. So Git will not allow that particular folder to be pushed into the GitHub. So now what I have to do, I need to ignore this particular directory. To ignore that, what I will do, git ignore. We are going to create a file called as git ignore. Inside the git ignore, what I can do, .terraform / I am going to mention that particular directory. When I mention that, here you can see the green color has been vanished for this particular Terraform directory, which means that the Git is ignoring that particular directory. If you see the Git status, previously it is showing that .terraform is an untracked file. .terraform folder is an untracked file. Now if you can see .terraform is not there. Okay, .terraform directory is not there when I give the Git status, which means that the Git is ignoring that particular folder. Okay, so this is called as git ignore. So what is the main functionality of git ignore file here is git ignore file will ignores the whatever the data or else whatever the folder names and file names that are given inside this particular git ignore file. The Git will ignore those files and folders. Okay, right. So now what I have to do here is, so here we have initialized the Git. Git is initialized, and you need to understand the Git workflow also. So in Git we are having 4 stages. One is the working directory. So what is this the working directory? Where the code is written. Where the code is written. Okay, it is called as working directory. Working directory. In which directory the code is written, it is called as the working directory. Okay. In which directory the code is written, it is called as working directory. For me, what is the working directory? For me, the working directory is Terraform basics. So here I have written the code. So that is called as working directory. And then what we have done, we initialize the Git. So when we initialize the Git, this working directory is called as a repo. When we initialize the Git, then the working directory is called as a repo. Then the working directory is called as a repo. Okay. Then what we have done, so whatever the files that are there, so we need to make sure that the files are updated and the files are saved. So in general, what is the meaning of saving here? So if we press Ctrl S, then the file is saved. This is as per the file system. So if I want to save a file inside my operating system or else inside the hard disk, then I will press Ctrl S. When I press Ctrl S, the file will be saved. But in Git, it is something different. So what is meant by Git or else what is meant by file saving in the Git? Whenever we want to save the file or else when we want to commit the files into the Git, then we have to first move to the staging area. Okay, so first one is staging area, so that the Git will understand that, okay, these are the changes that has been made inside the particular file, and that particular changes I have to commit them in the sense I need to save those files. So then first one will be staging area, and the next one is committing. I want to commit whatever the changes are made. Okay. So now if you can see here, so we are having these files as untracked files. Now what I will do, git add dot. Git add dot means whatever the files that are there in the current directory, all the files should be moved into the staging area. So when I give enter over here, here you can see previously we are having U symbol. Now the U symbol has been changed to A symbol. So what is the mean by A? A means that these files are into the staging area. So if you want to revert back, you can revert back from the staging area, or else you can go with the committing. Git commit -m initial commit. We are giving a message that, so we made the initial commit and we have saved the files into Git. So now what I am trying to explain you here, the Git will review the changes and it is going to save the changes, and Git will know which change has been made, where the data has been changed. Everything can be analyzed by the Git. How Git will understand that? So here you can see I said, in Git, in .git directory, there will be a .git directory will be creating. Inside the .git directory, there will be the objects folder. Inside the objects folder, here you can see previously we are having info and pack, but when we make the changes, automatically certain configurations has been, certain folders has been created. So what are these folders? Now when I go back here, git log. So here you can say this is the first commit that has been made and this is the commit ID. So DA1F35. So here you can see there is a folder created with DA, and if you can go inside that, we are having a file called as 1F35F2. So what is there inside this file? If I want to know about that, git cat -file, I will give this commit ID. When I give this commit, git cat -file -p, when I give this commit ID, here you can see, so the person, there is this initial commit is there. So the initial commit is there, and this commit has been changed by, this commit has been done by Chaitanya, and there is this particular commit is representing, or else this particular commit is forwarding, or else monitoring, or else it is connected to this particular tree. Okay, so inside the cat file, whatever you are having, so inside this DA directory, you are having this particular file. This particular file is connected towards this another directory. What is the another directory? There is 79 directories created. Here you can see there is 79 95547. 79 95547. So if you want to know what is this particular commit ID, so git cat file -p, if you give this, it is going to show you that, okay, so in this tree is referring to the three files. So previously, if you see, this particular commit ID is referring to the tree, and tree is referring to the three files. What are the three files? Main.tf, terraform log.hcl, and gitignore. These three files are created in three different folders. What are the folders that these three files are created? In 3f folder, I am having the main.tf related configuration, and in 8b folder, I am having the gitignore configuration, and B2 folder, I am having the .terraform log.hcl configuration related details. So I want to know what is this actually, what is available inside this commit ID. So git cat -log, -file -p. When I give this commit ID, here you can say whatever the data that is present inside the main.tf, I'm able to see that. So which means that the Git will track the entire changes, whatever the changes that has been made in your file or else in the code. So those changes, those data can be stored inside the .git directory in this particular reference points. Okay, so from where we are tracking it, first we will have a commit ID generated. This commit ID will be referring to a tree, and from the tree it will be referring to the blob storage. So here you can see, we can see blob. Blob means binary large objects. Okay, so it is referring to that particular blob storage. So when I go for this particular blob ID, then I will be getting which type of data available inside that particular file. What is the changes that has been made inside the data. So everything can be analyzed with the help of this blob storage. Okay, so this is how Git will be working. Do you understand the point here? Any questions?
Got it, and I got it.
Are you sure?
Yes, I am.
Cool. So this is about Git, and basically we are deviated from the Terraform. Why? Because I just want to explain you about the Git when we go in detail about the Git, I mean, when we go in detail into the course, at least you will come to know what is meant by Git and GitHub. How that is my intention towards saying this particular topic. So the next one will be when we have written this main.tf. Okay, this is good. So then I want to create a resource, which type of resource I want to create? AWS underscore VPC. I want to create a resource with the name AWS underscore VPC, and this resource will have a name. So this resource, in the sense, whatever the resource that we are creating, that's a Terraform resource. So Terraform should identify that. So whatever the name that we are providing here, this is not the VPC name. Whatever the resource name that we are providing in the Terraform, I mean, in this particular double quotation, that is not the name of the resource. When the VPC is created, that is not allocated as a name of the resource. This resource name is for the identification purpose for my Terraform. Okay, so Terraform will understand that, okay, I created a VPC with the name, for example, Terraform ID underscore VPC. This is the name of the resource. Okay, but not the resource name which is created in AWS environment. So when I want to create the VPC, I need to have the CIDR block. CIDR block is somewhere like 10.50.0.0/16. Okay, and the next one will be enable DNS hostnames is equal to true, and the next one will be tags. So here comes the name of your VPC. Name is equal to, I'll give like what is the name of the VPC? My DS-1. My DS-VPC-1. So this is the name of the VPC which I want to provide. Okay, this is good. So now when I save it, now what I have to do here, so the main and most important point here is, so this Terraform, so try to understand this. Terraform is available and the code is available in my client mission. This is my client mission. Client, here I am having my Terraform code. Okay, where this code has to reflect, what this code has to do, whatever the code that we have written, what is the functionality of this particular code, whatever the Terraform code that we have written, what this Terraform code has to do, what is the requirement of this Terraform code?
Have to reflect in AWS.
In my AWS account, it has to create the resources, right? So which means that when I go for Terraform plan or Terraform apply, what should be happen? So I need to log in into my AWS account, and then this code should reflect the resources inside my AWS account. Do you understand it? So for that, what should happen? To log in, I need to have the authentication and authorization. So for that, what you have to do here is, I need to create an IAM user. Go to the IAM user, create IAM user, Terraform underscore DS underscore user underscore 1. Next, this is the user which I am creating. And for this user, I will provide the administrator access. One thing that you need to understand here is, in companies, you cannot provide the administrator access. If you provide the administrator access, that will be a security breach. So what you have to do here is when the user is creating, so what are the type of functionalities that the user has to be done, or else that the user has to do, depending on that particular role, you have to provide the permissions for the user. But you cannot provide the permissions like administrator permissions for all the users. That will be a security breach. But as it is a demo purpose, I am going to show you. I am going to provide the administrator access. Next. And create the user. Now the user is created in the AWS environment. So the user is created in the AWS environment. Then how user details will be available for me. So what I will do here is I will go to the security credentials and create access key and secret access key. So why we are creating this access key and secret access key here, you can clearly see that. Use access key and secret access key to send programmatic calls to the AWS from AWS CLI, AWS tools from PowerShells, and AWS SDKs. So if I want to call, or else if I want to send any request to AWS environment, so what I have to do? So the user has to log in into my AWS environment, and then they have to call to the particular resource. Either it might be VPC or EC2 instances. So to log in or else to get the authorization for my AWS access, I need to create the access key and secret access key. Create access key and secret access key for third-party service. I am using it for my Terraform service. I will select third-party service. Next, create access key and secret access key. So now what I can do here is I can include this access key and secret access key in my code. So now what I will do, let me go to the Google Terraform AWS provider. Here I will give the where is it? Yeah, access key and secret access key. Let me copy it. Okay, I will give like this. I need to specify in which region I want to create these resources. So for that, what I can do here is region is equal to US-East-1. If I give this, so the resources will be created in the US East 1. This is fine. What is the access key here? The access key is this one. And what is the secret access key? Secret access key is this one. So we have provided the access key and secret access key in the code itself. Now when I run the configuration, Terraform validate or else Terraform FMT. Terraform FMT in the sense, so whatever the indentation is there, here we don't have a proper indentation. Okay, here we don't have a proper indentation. To make the proper indentation, what I can do, I can go for Terraform FMT. Sorry, Terraform FMT. So now it will be in the proper indentation. All the equal to's will be in a single line. So like that, I will be having the proper indentation. And then Terraform validate. I want to check whatever the code that has been given by me is correct or not. So the code is correct. We don't have any problem with the code. And then Terraform plan. So when I go for Terraform plan, so here you can see it is generating a VPC. It is creating a VPC with the name myds VPC1 with the CIDR 10.50.0.0/16. So now if you can see what are the steps that we have, that I have said you, first I need to write the code. We have written the code for VPC, and then we need to validate the code. Validating of the code is also successful, and then the planning of the code has to be done. That is also successful. Now I need to apply the code. So to apply the code, what I can do, Terraform apply. So when I apply the code, automatically a resource will be created inside my AWS environment. So when I give yes, there you go. So AWS _ VPC Terraform ID VPC creating. So a VPC is getting created inside my US East 1 location. Let me go back to the VPCs. Okay. So if I refresh this, here you can see myds VPC1 is created. So still creating. So we need to, yeah. So now the resource is created with the VPC ID. So the Terraform has created the VPC, but the main point what you need to understand here is a new file will be generated here. What is that? That's called as state file. This is the heart of your Terraform. Whenever the Terraform is creating any resource, first it will cross check with the state file. So do I have that resource in my state file or not? For example, I am giving subnet here. I want to create a resource AWS underscore subnet, and the subnet name is Terraform underscore ID underscore subnet underscore 1. This is the name of the Terraform subnet. And in which VPC it has to create VPC ID is equal to. So if you want to get the VPC ID, go to the Terraform state file, AWS underscore VPC. Go to this particular resource, AWS underscore VPC, Terraform ID underscore VPC dot ID. So from here you can get the VPC ID. Look at that. So now what my Terraform will do, okay, in the state file there is AWS underscore VPC type is there. VPC is there. And what is the name of the VPC? This name will be understandable by the Terraform. This is for the Terraform identification purpose. The whatever the name that you are seeing here, this is for the Terraform identification purpose. This is not the resource name. The resource name is this one. Okay, try to understand this. So then what it will do, okay, I will go to AWS VPC block. Inside the VPC block, there is a resource created with the name Terraform ID underscore VPC. Under that, I am having the VPC ID. So I want to create the VPC in that particular, I want to create the subnet inside that particular VPC. AWS underscore VPC dot Terraform ID dot ID. This is the VPC ID in which the Terraform has to create the subnet. And then what is my requirement? CIDR block is equal to 10.50.1.0/24. This is the CIDR block. And then availability zone is equal to US-East-1A. And then the tags. Tags is equal to name tag, that is equal to my ds-subnet-1. So this is the name of the subnet that I want to create. So if you can see previously in the shell scripting, we are having the code in this format only. So when you see the shell scripting, in the shell scripting, I am having the VPC and I am trying to create the subnets. But what is happening here when I am trying to create the subnets and whenever I am trying to execute this particular code for the multiple times, duplication of the resources is happening. So the VPC is recreating. But now in the Terraform that will not happen. Why? Because the Terraform will go into this Terraform state file and check that, okay, already there is a VPC. So now if you can see Terraform format, Terraform validate, and then Terraform plan. When I give this, see that AWS Terraform ID underscore VPC refreshing the state. It is not creating that. It is going into the Terraform state file and checking that already there is a VPC. So I need to create only subnet. So here it is creating only the subnet. Okay. So this is what going to happen. So when I apply Terraform apply, then it is going to create the subnet inside that VPC. This is called as idempotency. So whenever there is an increasing or else whenever there is an enhancement in the Terraform code, depending on the enhancements, what Terraform is going to do, whatever the previously created resources are there, those resources will not be duplicated. So Terraform is only going to create whatever the newly edited code is there, or else whichever the newly created resources has to be created, those resources will be created with the help of Terraform. And then it is not going to duplicate it. This is called as idempotency. So now when I refresh here, if I go back to the subnets, let me refresh it. Here you can see we are having my DS subnet, which is created inside this my DS VPC1. So like that, what is going to happen? Why this is happening, or else how this is happening? This is happening because of this state file. Whatever the state file that we have that has been generated, depending on the state file, because of this state file, that configuration is happening. So I don't want to copy these state files. I don't want to make state files available or else tracked by Git. So for that, what I will do, star dot tf state and as well as star dot tf state dot star. If I give this, these two files will not be tracked by the Git. So that is what my requirement. I don't want all the people to know about my current state. Okay, I will provide the code over here. So this is how you are going to write the Terraform code, and how Terraform is going to analyze what are the resources that are created and what are the resources that need to be created with the help of state file. Understood about the concept? Any questions here? Do you got the point? Any questions?
Yes. Is it okay to keep the sticker key in the main tier? Because we are going to post this code in the
Very good,
anyway.
very good question. Very good question. Your question is it the right thing to keep the access key and secret access key in the code? That is what your question is, right?
Yeah.
We can, what we can do here is, we can remove this access key and secret access key directly from the code. What we can do here is, in our computer, we can install the AWS CLI. So if you don't want to put the access key, and I'm waiting for this question, if you don't want to provide the access key and secret access key in the code, what you have to do here is, you need to install the AWS CLI in your laptop. Okay, in your laptop or else in your Windows operating system. Okay, simply copy this code and paste it over here. So then execute the code. So then it is going to install the AWS CLI in your laptop. Already I'm having the AWS CLI. I'm not going to install it. But the installation process is same. Next, and install. That's it. You don't need to change anything. So it is going to create in the C drive. So nothing is going to be changed. So next, and install. The AWS CLI will be installed on your system. That's fine. So now what I have to do here is, after installing the AWS CLI, I need to give the command AWS configure. When I give the command AWS configure, it will ask me the access key and secret access key. So I already have the access key and secret access key in my system. So it will ask me. So whenever you are creating for the first time, here you can see none. The access key ID is none for the first time, but I already have the credentials in my local system. So I don't want to change it. But what it is going to happen, if you provide this access key in your system, I can provide like this, and then the secret access key will be this one. Okay, so access key and secret access key, region name, if you don't want to give, you cannot give like this. So this is what going to happen. I have provided my credentials. So now I removed the credentials in the main.tf file. In the provider, I did not gave the access key and secret access key. But what is going to happen in my computer, in the C drive, users Chaitanya .aws, here you can see there is a credential configured. So if I open this, there you go. We are having our credentials configured here. So when the credentials are configured, now what is going to happen? Where Terraform is running? Terraform is running in my computer. So now whenever I go for Terraform plan, then it will initialize, then it will go to that .aws directory. From there, it is going to take the credentials and try to log in into my AWS account and fetch out the details, and it will compare the subnets which are created, VPC's resources that are created with the Terraform state file, and everything is fine. Then it is not going to create anything. So here you can see there are no changes. So whatever the infrastructure that you have given in the code, the infrastructure is already available in the AWS environment. So this is how what you can do. You don't need to provide the access key and secret access key in your code also. Is it clear now?
Yes.
Okay. So this is about how you can create the AWS infra. Just I am giving the basic understanding, but this is not the correct way of giving the code. So why? Because we are all hard coded this. So these values are hard coded. So if I provide this environment to the, if I provide this code to the another person, so that other person has to change all the values. So I don't want to make that happen. So what I want to do here is simply I need to variabilize the configuration. How I can variabilize the configuration? How I can make that make the other persons will use the same code for a different environment. For a different VPC to be created. We will see in the Monday session. Okay. So this is the last and final demo, which is for your Terraform, Docker, and Kubernetes and Jenkins classes, Jenkins sessions. And from Monday onwards, we will be connecting. At 4:30 p.m. So from Monday, the sessions will be 4:30 p.m. IST to 6 o'clock IST. Okay.
And one more thing, Chaitanya. How much prior knowledge needed for this? AWS client. I know how to work on AWS, but I never been worked on AWS client side.
AWS VPC understanding is necessary. EC2 understanding is necessary.
No, I clear that part. AWS client, CLI.
CLI we don't need. Here we are not going to use any CLI. So to make sure you understand what is the main difference between the shell scripting, AWS CLI shell commands and the Terraform, I have shown you the CLI. But apart from that, we are not going to use CLI anywhere.
Okay.
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 Right. Any further questions? Okay. Fine then. So we will meet on Monday's session, 4:30 p.m. IST. Don't forget to attend the session on 4:30 IST. Have a nice day and bye, guys.